Okay, I think we'll get started. It's 2 o'clock now. So hi everyone, I'm Nicole from Primary Engineer and welcome to our online interview today. We have Alan Stewart here, who is the Group Head of Advanced Manufacturing, Innovation and Research at the Weir Group. So before we get started, I'll quickly run through what's going to happen during this session. So the first part will be Alan's presentation, and that will then be followed by a Q&A section. There's a Q&A facility at the bottom of the screen, so at any point during the interview, make sure to get your questions in and we'll get straight into it after the presentation. I'll quickly run through what the If You're an Engineer, What Would You Do competition is. So the main aim is to inspire young people, ages 3 to 19, to look at the world around them and start designing solutions to problems. So these can be something as simple as making toast or getting dressed, to a worldwide issue like pollution or plastic waste. Providing these opportunities for you to meet and interview professionals online, just like today with Alan. We hope to inspire you to think of some ideas and start designing some inventions. So without further ado, I'm going to stop sharing my screen and hand over to Alan for his presentation.
Thank you, Nicole. So just let me share my screen and hopefully that is visible to everybody. Yeah, so thanks. Today I'm going to take you through an area of work that I am involved with, I think extremely interesting and will become more.
Sorry, Alan, I'm not sure if it's me, but it's not sharing on the screen yet.
Okay, sorry, let me try screen 2.
There you go. Okay, I'll hop off now.
I just didn't, I think a single click, not double click. Right, let's try again. There we go. Is that visible now?
Yeah, it is. Perfect.
Perfect, thank you. So, sorry about the false start. Yeah, so today I'm going to spend a little bit of time talking about a technology that is very important to the Weir Group and one that I'm extremely interested in. But before I do that, I'm just going to give a brief introduction to myself, what I do, what I find interesting, a little bit about the organisation that I work for and what we do, and then do a slightly deeper dive into the additive manufacturing technology. And as was said in the preamble by Nicole, really interested in getting questions, because I think as I've learned through my career, I'm only one opinion, and the more opinions that come together, the better the ideas will ultimately be. So running through the slide relatively quickly, as I've now said a couple of times, I'm Alan Stewart. I'm the Group Head of Advanced Manufacturing, Innovation and Research at the Weir Group, a Scottish engineering company that has now been around for 150 years, operating globally, but with our historic and cultural roots very much in Glasgow. I studied as a mechanical engineer at Strathclyde University some years ago, and outside of work, I enjoy mountain biking, walks with the family, and also a little bit of online gaming with my daughter. Why do I enjoy being an engineer? I was thinking about this question when putting the slides together, and I think I was always going to be an engineer, even before I realised it or studied it, because I've always enjoyed, as I said, they're simply breaking things and making things. But what I mean by that, and I've always had a real interest in taking things apart, understanding how they work, and putting things back together again. Sometimes using all the parts, sometimes saving parts. But I think being an engineer quite often is in your DNA. And as you go through your education, you're actually just getting some of the tools you need to become a good engineer, but it's always in your heart. So very quickly, overview of the Weir Group. As I said, the Weir Group is a relatively old organisation at 150 years. It was founded by 2 Scottish brothers, James and George Weir, who were both engineers and innovators back in 1871. Their first significant invention was a thing called the direct acting feed pump, which was really important on ships. As you can imagine, in the 1871, a lot of the world's cargo was transported on steamships. And this direct acting feed pump allowed ships to be more efficient and travel further, so they used less fuel and got the cargo to where people wanted it to be. But that wasn't the only invention. It was always in the DNA of the 2 brothers, and it's something that certainly has become very prevalent in the organisation that I work for today, some 150 years later. As I said earlier, we've always been based or headquartered in Glasgow, but we've now got a global footprint. And over the decades, we've been involved in some really interesting engineering technologies. from developing desalination plants to create potable water, drinkable water all around the globe, all the way through to prefabricated housing after the war. And if you look at that picture in the top centre, we were also involved in the development of the technology that sits with what was called the Weir Sikorsky autogyro, which eventually went on to be developed into the modern day helicopter today. So you can see some of the diversity of the technologies and innovations that came out of the brains of the two Weir brothers and the teams that worked for them. So today, as a business, we've changed again. Our main focus is in the mining market. We have been involved in oil and gas, we've been involved in power production, but we recognise that where our current strong capabilities are sit within in mining. And from a kind of technology and innovation perspective, we really do pride ourselves at being the best at what we do and using our technology and our innovation to do what we can to make our customers more successful. And right now, what does that mean within the world of mining? It really is about reducing energy consumption and water consumption to ensure that what, as an industry, is critical to society, the extraction of minerals, has minimal impact on the environment, which presents real challenges. But with the engineering teams that I work with and I'm part of, I'm sure we will come up with some great innovations to do that. So moving to just very quickly the products across the mining circuit that we work within. We work across what's called extraction, comminution, the mill circuit and tailings. Some people may be familiar with that. Our ESCO business, which is on the left-hand side, is involved in what's called ground engagement tools. So this is about excavating the ore from the rock face and from the mine site. And then some of our products are used in what is comminution, which is grinding and crushing. So taking very, very large pieces of rock and milling them down to something that is, I guess, the size of ground coffee. So again, you can imagine the energy and water consumption that is used to do that. And some of our products are market leading in the reduction of energy, such as our high pressure grinding rollers. And then moving to the mill circuit, that fine material is then mixed with water and is processed. And again, a lot of our equipment is used to extract the water, to increase the concentration of the slurry, and then processed into materials that we use today in mobile phones, electric cars, etc. And then at the end of the process, our products again are used in what is tailings management, obviously a byproduct of the mining process. We end up with a lot of processed water, which has to be reprocessed and ultimately made safe. So if I come back to that sort of innovation perspective, you can understand why an organisation such as Weir, which is involved in a heavily extractive industry, is really keen to make sure we have got the minimum impact on environment, and we continue to create products that use less energy, consume less water, and create less CO2 than we did in previous years, ultimately making the world a slightly greener place than it was previously. So where do we do it? As I said, we're a Scottish company, but we're spread all across the world. We've got 11,500 employees working across 50 countries, and there's over 200 Weir locations. And if you can see those little orange dots, that's everywhere there are Weir people around the globe. Moving to the technology I'm going to talk about today is we have 11 operating foundries. Foundries are massive factories that take material and melt it down to a liquid and then pour it into a form or a structure that we need to make our products. As you can imagine, that is high energy consumption and large material consumption. And again, we're looking at emergent new technologies to see how we can minimize the impact and reduce the CO2, reduce the energy, and reduce the water involved in that process. And we're always looking for new ways to do it. So that leads me into what I was going to talk about today. And I've titled it sort of slightly tongue-in-cheek, is additive manufacturing worth all the fuss? Why do I say that? You know, I've been involved in advanced manufacturing for some 10 years now, and I've seen additive manufacturing, or 3D printing as it's often known, become something as a lab scale application into something that's now being used in industry and in sort of mass adoption of it in certain industries such as aerospace and automotive. But really, what does it mean for us as engineers looking forward? What does it mean for the Weir Group? And how can we best deploy and apply it to ensure that we're driving benefit to whether it's our customers, whether it's to our employees, our engineers, and ultimately society. So if we look at this slide, additive manufacturing, what is it and why is it important? And what I did was I kind of Googled the definition of additive manufacturing, and I won't read it out verbatim. I'll just pull a little bits out of it. But what I would say is that as a definition, 3D printing or additive manufacturing, construction of three-dimensional shapes using computer-aided design, 3D models. It's about layering, it's plastics. It's a very dry definition. And I thought for the audience today, you know, what does that really mean for us as engineers? What does it mean for us as budding engineers, future engineers, or current engineers? And I've tried to put a little bit of context on it from a Weir perspective. So what does this really mean? And I kind of split it into three simple segments to do with my day job. And in real simple terms, if we can take a product that has been designed conventionally, you know, which has involved cutting, it's involved welding, it's involved brazing and joining, and actually make that as one homogeneous component, you know, less parts in simple terms equals less waste, and less waste is good for the customer, it's good for the company, and it's good for the environment. Additive manufacturing also brings other benefits. If you can take an assembly of components and turn it into one single component, it's much stronger. And stronger components are better components. And if we can create stronger components and better components, it's better for our customers. And ultimately, that's kind of coupled into what I call better performance. You know, whether it's through the less parts and less waste, whether it's through new materials, whether it's with stronger components, or the design freedom that I'll talk about later on that gives us better performance from a fit, form, and function perspective, that can only be good for the product and for the customer. And as I said earlier, Weir's been around for 150 years, and we've always tried to make our products better than everyone else's and better than our current product portfolio. And I see additive manufacturing as a key lever to enable us to do that in our future product design. So moving on to that, into sort of engineering terminology, and forgive me if you're familiar with this already, but there's a terminology within engineering called design for manufacturability. And again, I've chosen a relatively dry definition that I'll skirt over quite quickly and then talk about what it means for me. But again, the definition of design for manufacturability is the optimization of a part of product or component design to create it cheaper and more easily. DFM involves efficiency, designing and engineering an object, generally during the product design stage when it's easier and less expensive. I won't read the rest of it, but what does that really mean in the terms of what engineers do every day? So if you look at the example of the bike and you look at the bike on the left-hand side, something that many of us will be familiar with, it's a very conventional design. That bike will have been designed looking at material that's available and joining techniques that are existing and matured within engineering good practice. What additive manufacturing does is it removes these constraints. You look to the bike on the right, which has been designed without constraint. It's not had to think about how do I join the top tube to the crossbar? How do I join the forks to the headset? It's been, what am I trying to achieve? What does it need to look like from a fit, form, and function perspective? And then have the absolute freedom to design anything that you can think of. And if you go back to design for manufacturability, I looked at it in really simple terms. If you can't make it, it will always just remain as a good idea. And what additive manufacturing is allowing us to do is really think about, broaden our minds on what we think we can design and marry that up with a much more increased likelihood of being able to manufacture it. And if you look at the comparison between the two bikes, the one on the right-hand side, as I look at it, the additive manufactured bike uses a lot less material. It uses a lot less joining. It will probably weigh a lot less. It will most likely be slightly more aerodynamic. So aside from looking pretty slick and looking pretty nice, the actual design content is better than the original design. And that's something that we are trying to do every day within Weir, is how do we take our existing conventional thinking and unconstrain it and start looking at what the art of the possible may be. So additive manufacturing allows engineers to design without constraints of traditional manufacturing and really open our minds to the art of the possible. Then if I talk a little bit very quickly about lead time, what does additive manufacturing do for lead time? Well, the definition of lead time in simple terms is the time from order to the time of receipt. Think about Amazon as an example. You know, we look for today, we order something today, we expect it tomorrow. If you look at that from an industrial component perspective, historically, our products can take months to make. We need to buy the material, we need to wait for it to arrive, we need to assemble it, and then we need to ship it to the customer. Additive manufacturing can disrupt that sort of standard MRO model, and it actually can help us reduce the size of our factories. It can reduce the number of machines that we need. It can reduce the material demands, but it can also reduce the lead time. We've got example components within our factories that used to take 36 weeks to make, and it now takes 36 hours to print it. So by dramatically reducing these lead times, we can start servicing our customers and servicing our product much, much quicker. So additive manufacturing reduces lead times from conventional manufacturing products and gives us a more distributed footprint of where our factories are. We no longer need to ship things around the world. We can actually move our factories close to where the products are needed. And then thinking about additive from a waste reduction perspective, waste reduction is unwanted or unusable material. Waste is a substance which is disregarded after primary use and is worthless, defective, and of no use. So from a sustainable world, conventional manufacturing, if you're manufacturing that complicated 3D shape, will result in a lot of subtractive waste lying on the shop floor. You take a kilogram of material and you might have 90% of it cut away to give you the end product. Additive manufacturing can help remove that. The less waste that we generate, the less material we've needed in the first place. So if we're using less material and we're processing less material, we should in theory use less energy. And if we use less energy, electricity, we create less CO2, which in turn obviously has a negative effect on the environment and the planet. So additive manufacturing can reduce carbon dioxide and energy consumption, delivering greener factories and greener products. And finally, just on cost. Cost isn't quite as straightforward with additive manufacturing, and I describe it a little bit as, it's a bit like choosing the right athlete for the right race. You wouldn't send a marathon runner out for the sprint, and you wouldn't send the sprinter out to do the marathon race. They've got different attributes. Additive manufacturing is very similar. So if we look at the cost of conventional manufacturing, if we're doing high volume and low complexity, such as a sphere or a cube, something without a lot of complexity, conventional manufacturing is absolutely the most cost effective. If we're looking to something that is highly complex, perhaps a lot of holes in it, a lot of channels, a lot of changes in geometry, and we're not looking to make tens of thousands of them, additive manufacturing is likely to be the most cost competitive in that area. So if I was just quickly wrapping up and thinking about what I hope you have learned about additive manufacturing today, the most important one for me is the first one. It allows engineers to design without constraints of traditional manufacturing, really opening up the mind to what you can do and what you want to do, taking those good ideas and turning them into great products. Excuse me. Additive manufacturing can reduce product lead times to conventional manufacturing. We can get things to our customers quicker. We can get products to the consumer quicker. Additive manufacturing can reduce CO2 and energy consumption, delivering greener products, which I think from a sustainability perspective is very important. And in some cases, it can reduce cost if used wisely. It's not about using it for everything. It's about working out its suitability for the product and deploying the right manufacturing technology. So I think for me, in the final strapline, additive manufacturing is a part to play on manufacturing of all new products, but it's certainly not the answer to everything. But what I would say to every young engineer and every budding engineer is understand the technology and make sure you go and make the best products you can using the best technology available to you. And at that, I'm going to draw a breath and ask if there are any questions.
Thank you for that, Alan. That was really interesting. So before we get into the Q&A, I'll just remind everyone that there's a Q&A facility at the bottom of the screen. So if you've got any questions whatsoever, then just type it in there and then I'll pose those to Alan. So a question from me, what kind of student were you in in high school? What subjects did you study?
I did chemistry, physics, maths, English, and geography. And it's certainly the maths I use every day. And I think as an engineer, it's something that I enjoy doing. I said it in my first slide. I like problem solving. I still like problem solving today, even though school was a long time ago. And
kind of off the back of that, are there any, I suppose, qualities or skills that you think outside of the classroom is really beneficial for people to learn? You know, collaboration or creativity?
Yeah, I think the first thing is have a really inquisitive mind. I'm sure if my parents were on this call, they would say as a child, I was always asking why. And even today, I'm still the same. So I think it's always good to just question everything. I think your question about collaboration is key. You know, the sum, the whole is greater than the sum of the parts for me. I love working in teams. I think ideas are generated by the team. Solutions are generated by the team. Not one mind solves every problem. And one question leads to another question, and somebody throws in another idea, and suddenly you've got a great solution to build on. So I think, and I like team sports because I enjoy spending time with people and challenging people, asking them why, and hearing their answers.
Mm-hmm. Yeah, so we've got lots of questions coming in. So Miss Barnes has asked, what are your top tips for engineering for us? The students?
Engineering what, sorry?
Engineering top tips.
I think so I kind of said it in my preamble. I honestly believed I was an engineer before I knew I was an engineer, because I just liked understanding how things work. So my top tip would be, from a school point of view, is even though a subject's hard, such as maths, do it, because if you want to be an engineer, it's a great thing to have, and you will get to understand it eventually. I think, you know, have that inquisitive mind, understand the value of working as part of a team, and don't always take the first answer as the right answer. I don't mean when your parents are telling you to go to bed. I'm thinking more about when you're thinking, why did that do that? Why did that happen? Really always challenge yourself that the first answer might not, or the easiest answer might not always be the right answer.
Mm-hmm. And Amber has also asked, what is your favorite engineering creation?
My personal engineering creation, well, one that never got off the ground, and I use it quite a good example about innovation. Innovation without demand is just a good idea. I always thought there was a place for a keyboard and a toaster so I could eat my breakfast while I was working, but I couldn't really get anybody to sign off on that. I think from an additive manufacturing perspective, when we sold our first additive component to an oil and gas customer, and we were able to sell it because they needed it in an emergency and we could turn it around overnight, I was really pleased about that. I mean, I think if I come back into family life, my daughter and I are kind of or not so much now, but when she was younger, we were Lego addicts. And I think just some of the crazy things we came up with, putting a block against a block and adding another block to it. And the one just during our holidays there, we built a tree house out the front garden that I think I'm more proud of than she is, actually. But there we go.
The toaster and keyboard just sounds like a nightmare, though. The crumbs would be unimaginable.
I think that's where that's the bit I should have consulted with the team. You see, I came up with that idea on my own.
Yeah. So primary 5 and primary 6 have asked, is it hard to be an engineer?
Got to study quite hard, if I'm honest. I think if you have the ambition to be an engineer, as I was as a child, I like dismantling things, I like building things, you'll always get there. But it takes discipline, as all careers do. But the great thing about being an engineer is there's never 2 days the same. So I would say, yes, it's not easy, but it's certainly worth taking the time and studying hard, because what you get out of it is no 2 days the same, and you have the opportunity to change the world.
Mm-hmm. Yeah, definitely. One classroom has asked, at the moment, you know, with the COVID-19 pandemic, what can engineers do to help with hygiene? I suppose that could be something as well that they could potentially solve during the competition.
That's a great question. It's actually one of the things we had as a challenge across the Weir Group. So we asked 11,500 of our employees, what can we do to make the world safer and make our world safer? So I don't know if it answers the question directly on hygiene, but we printed door openers so people could open doors in the facility using their elbows and using their feet to try and minimize hand contact. And we the beauty of going back to lead time, we didn't take weeks to do it. We did it in hours. We printed face masks, holders for the NHS and distributed them to the NHS hubs. And we also we bought personal distance monitors. So everybody had like a Fitbit watch. So if you were in our factories and you became within 2 meters of somebody, you got an alarm that reminded you to step back. But I think from a hygiene perspective, coming up, and this was our own team, came up with these elbow and toe openers on doors, and being able to come up with the idea, print them within a couple of hours and see them in the shop floor the next day was just the power of people. It was great.
Yeah, that sounds really innovative. I've not seen something like that. So again, we've got lots of questions from Amber. What is the most difficult engineering creation that you've created?
Wow, the most difficult engineering. Well, I work in R&D, so I would say everything I'm working on right now we haven't created. I've got a team of researchers, so we're trying to make materials that can heal themselves. So that's probably one of the most challenging that we're working on right now. So we make products that wear out because they're in the mining environment, and we're working with a couple of universities to see if we can make self-healing materials. So if you've watched Terminator movies, when the robot rebuilds itself, that's what we're trying to do, but we're trying to do it with composites and with rubbers. So that's probably the most difficult thing we're working on right now. But again, going back to the team, we've got people way smarter than I could ever be working on this. I just nod when they talk, but they certainly seem to know what they're doing. But that's probably one of the biggest things we're looking at right now. And also using microwaves, like the microwave in your house, using microwaves to actually break rock. So instead of having to crush it and use a lot of energy to crush it, a little bit science fiction, I know, but can we actually fire microwaves at it, and then it's easier to break the rock? So we're doing some pretty exciting stuff. We've not solved any of it yet, but we're confident we will.
Everything's initial.
Oh yeah, no, we're quite far on. We're quite far on with some of them.
Oh, well, I was going to say maybe some of the kids watching could try and figure it out as well.
Absolutely, yeah. Answers in an email, please.
Yeah. So Primary 5 and Primary 6 again have asked, I suppose, what is the day-to-day life like for you?
Well, right now it's very strange because we've all been working at home for a year. But when I'm in the office, a lot of it is spent catching up with some of our really clever researchers. And that's what I really like, is I thrive of listening how people are. So there'll be a lot of meetings as people have, but it's not meetings about boring things. It's about meetings about self-healing elastomers. It's meetings about some really high-end simulation work that we're doing in some of our products. We've got a laboratory in Todmorden, just outside Manchester, that I can go down and see the robots welding and doing additive manufacturing and seeing products come off the door. So I'm really lucky. I've got the balance between working with some really smart people and then actually going to see the products coming off the production line using new technologies, which is a great place to be. I always say I've got the best job in Weir, but I don't like too many people knowing that. So somebody else might want it.
Someone will nick it, yeah. So we're kind of running out of time, but I think I'll do a couple more questions because we've got quite a few coming in. Amber has also asked, how many creations have you been part of to date? I suppose you've got a long history in Weir, so...
Oh my goodness. My goodness. Yeah. Me personally, probably from a new product perspective, 50, 60 new products, something like that. But there are people who have done a lot more in Weir over the 150 years, but it's about finding the right ones. It's getting the good ones.
Yeah. And I suppose this is something that I kind of like to ask my interviewees is, what's the most memorable moment in your career?
So we have a thing called the Chief Executives Award for Innovation, and I was part of a team that won that award. We built, and it doesn't sound that great when you know what Amazon can do, but within our world, it's quite significant. We built an e-commerce platform, so we built an Amazon for Weir products selling to our customers. We had 6 months to do it. People said we couldn't do it, but the power of the team and the ambition of the team and the hard working of the team, we delivered it. And when I remember to this day, I was actually in an airport when I got the email to say we'd sold our first part on it. That felt real. You know, it wasn't just something we talked about doing, and that felt really good. So I was really proud of what we achieved with that one.
Yeah, that's a good one. That's kind of validated everything that you've put into it.
Yeah, absolutely.
So again, we've run out of time. So just quickly, do you have any final advice for the people that are watching?
Be engineers. It's the best job you can do. No two days are the same, and there's very few jobs that you get the chance to create something and change the world. So for me, it's such a broad subject as well. From medical to aerospace to mining, there's so much you can do. So work hard and stick with it. It won't be easy, but it's well worth the reward.
Yeah, there's a place for everyone.
Absolutely.
So thank you so much for taking time out of your day, Alan. It's been really amazing. And yeah, the questions, thank you everyone for putting them in. They've been really unique. I've not seen quite a few of them before. So yeah, if you want to get any more inspiration, then you can go to the www.leadersaward.com website. And yeah, I'll leave it there. Thank you, Alan.
And thank you everyone for taking the time and coming to listen to me, and hopefully some of it will rub off on you and I might see you part of the team someday in the future.
Fingers crossed.
Hopefully.
Thank you everyone.
Thanks.
Bye.